record this lesson. If you have questions, don't be afraid of asking things, but you have to speak nice and loud. Okay? So let's try that again. Electric circuits, any path along which charges will flow, and that's usually the electrons. It comes from the voltage source. That voltage source is from the battery. The electrons are part of our wires, and then the voltage sort of drives those things through it. We need to have a complete circuit. A complete circuit is required for charges to flow. So if there's any gaps, the charge will not flow between the batteries, the supply terminals. Now, we often use a hydraulic analogy or a mechanical analogy. The pump is analogous to what kind of electrical device do you think? The pump. The pump is the source of pressure for a mechanical system. What would that be analogous to? What would be the same kind of thing in an electrical system? Battery. Thank you, Robert. A battery. So we would draw the battery like so. I'm going to draw it this way because when you go to interpret these things in your labs, you'll see a battery drawn like so. That represents like a 3-cell battery. There's 3 cells in that battery. Okay, so that would be a battery symbol for a voltage source. It is the energy source. So it's not just voltage, it's energy. So the energy source is what's needed to be able to drive those charges. And so that comes from a chemical reaction. A valve for a mechanical system, you open or close that, that will either allow water to flow or to block it off. That's analogous to a switch. And that's what we would draw for a switch. And I'm going to draw that actually the way that you would draw it, which is that you would have 2 circles and then a line drawn like so. That'd be a switch. And then finally, resistor. You guys remember that we studied resistance was one of the 3 things that relate to voltage, current, and resistance. And so a convoluted line in a pressure system would be similar to a tortuous path for the charges to flow, and so that would be the symbol that we draw for a resistor. You notice I have a complete path, so charges will begin to flow essentially down the hill. Okay, so again, we need a complete path for that. Now, we will often go back to a mechanical analogy to understand this stuff. Now, we want to look at 2 different ways of connecting wires together. One of them is a series, and so I think I had you guys do a series connection yesterday when I had you build the FET simulation. You guys had, do you recall, were there 2 or 3 light bulbs that were connected together for yours? Was there 3? So what I had you make was essentially a series circuit. So all 3 light bulbs were connected one after the other. And so we like to have students build these. It's hard to do it sometimes. So we will often always build them on a simulator, and then if we have time, we're going to try to have you actually build them. But that's, again, really tight to be able to do. A parallel branch, and I think it was Robert that told me, or Simon that said the other was a parallel branch. And so parallel provides multiple paths for the charges to flow. Okay, and so these would be the 2 main ways in which we can connect multiple elements. Now, there are advantages and disadvantages to both, and I want to show you those with building them and by looking at how these things would allow for certain kinds of applications. Let's go ahead and take a look at the series first. Okay, so a series. There is a single pathway for current. If one device fails, everything shuts down. So if we have a series arrangement, if something were to burn up, like a light bulb, or if I open up a switch, everything shuts down. The total resistance would be equal to the sum of the individual resistances. So if each of those light bulbs is 4 ohms, I'm going to write those things on here for us. If each of these had a 4 ohm resistance, 4 ohms, then the total would be 12 ohms. We would say that those light bulbs provide 12 ohms of resistance for that battery. The current is equal to the voltage source divided by the total resistance. This, again, goes back to that concept that I would be equal to V over R. So in this case, if that were a 9-volt battery, that would be 9 volts divided by 12 ohms, and that's how I get the current flowing through that circuit. The voltage is divided across the individual devices. The sum of the voltage drops would equal the supply. if this were a 9-volt battery, if that were 9 volts, this would have 3 volts across it, this would have 3 volts across it, and this would have 3 volts across it. I think you guys had to do that yesterday, right? You had to take a voltmeter and put it across some of the devices, and you saw that the voltage was dropped off across those things that was different than the voltage from the battery. And then finally, the voltage drop across each device is in proportion to its resistance. If one device is more resistive than something else, it's going to get the bigger drop. Now, I'm recording this, so oftentimes recorded videos, there's delays, there's lags in this because I like to do demonstrations. I'm going to have you guys come up here for a moment. I'll show you how a series circuit would be arranged. Come on up for a few minutes, please. Come on up, out of your seats. Come on up. Now, this is not the intended use of this up here. This is mostly for waves, but I'm going to use this as a connection point. Come on up, out of your seats. You're all tired. You're seated there, and you want to get out of your seats. You need to get out of your seats. You must get out of your seats. Come on up here, Carson. Come on. I need your help. I'm not tall enough to reach this. You're pretty tall. How tall are you, Carson? I don't know. That's not a height. I'm going to connect. This is a red cable connected to my power supply. I'm going to take this thing. I'm going to try to run it all the way up to this thing here. So hopefully that's tall enough. It is. Thank you. Now this is now going to be electrified. Natalie, don't you reach up and touch that. No. It's low voltage. It's direct current, but it's low voltage. All I'm doing is using this as like a place to connect my wires. Now I'm going to do a series circuit. So I'm going to take, I have some light bulb, Christmas tree light bulbs, anyone know? Those are connected in series, aren't they? Can you tell?
Yeah.
How do you know that they're connected in series, Simon?
Because when one of them fails, they all fail.
Yeah, when one fails, the entire strand goes out. And that's what happens, right? If one thing fails, everything shuts down. There are advantages to series, but this one is sort of a disadvantage. Now what I want to do is I want to take this, and I'm going to show you how I might connect this as a series arrangement. So again, I'm not doing this, I'm only doing this so you can see it, because people often have a hard time seeing these things when I do it on a table. If I just connected this up, this would be a standard circuit, right? Just a single light bulb, single circuit. I could turn this on, and there's only a single element, so it's, hey, we got light, it's pretty cool. What I want to do is I want to show you how I'd connect a series up. So series, I'm going to disconnect here. I'm going to take another light bulb, and I'm going to connect it in series with it. So I can think of the current flowing from the red up through that wire, connected to there. It's going to flow through that light bulb, and I'm going to have it flow through this light bulb. And then this needs to return it to that source. Do you think you can? Oh gosh, look at that. I forgot that I had the power on. You guys see that as soon as I connected it up, that everything lit up? Can you guys see it? I'm going to increase the voltage. I'm going to take the dial. Now you guys haven't used these things yet, but I'm going to take that dial. I'm going to increase it. What do you think that's going to do to the lights? Make it brighter, because I'm going to increase the driving force. That should increase the current flowing through there, and so you can see that those are getting brighter. Now that current, you can think of it flowing through that wire, through that bulb, through that wire, through that bulb, returning to the power supply. What will happen if I pull this one out? So when I do that, I've completely broken that circuit. Does that make sense? I put this one in, and it should start back up. As long as those wires, you guys ever play with these things here? And you have to make sure the wires are connected in there. All right, Abby, pull that one out. You're going to have to hold the base. And sure enough, that caused the other one to go out, right? Series connection. Could I do another light bulb? I just disconnect this one here. Just disconnect this one here, insert another one, and so I can put any number that I want, right? That's the idea behind a series circuit. All right, I'm going to show you parallel next, but first, no, I'm going to save that for a little bit. I'm going to show you a parallel next. Head on back to your seats, and we'll come back again and look at this with a parallel. Okay. Unfortunately, people having to watch this video because they weren't here today are not able to see the demos. I want to do a parallel arrangement now. Parallel, voltage across each device is the same. It's the voltage from the power supply. So this is a new kind of arrangement. I did not have you guys build a parallel circuit yet. You guys are going to do that on a circuit simulator first. the total current from the source is now divided among the individual components. So if I have something arranged in parallel, the current is going to be divided amongst those branches. The total current in the circuit is equal to the sum of the current in each of the branches. So I would add up all these things in the branches, and that would give me the total current. The advantage of a parallel is that if one device fails, everything else stays on because each has their own path. Okay, so there are advantages to parallel, there are advantages to series. Both of them also have their downsides. Okay, so this is a different kind of arrangement. Now I think this would be the best time for you to see how those things are wired. Okay, so I'm going to do the same thing up here, and then I want to finish up this video with that. So one more time. Sorry, come on up. I'm going to show you a parallel arrangement. Connor, will you grab the door for me, please? And then come on over here so you guys can see how I wire this in parallel. Okay, so Abby, I'm going to need your help. So this one again is the main light bulb that's coming from here, and I want to take this and I want to have that wired in black. Simon, will you grab me a black wire there? So for a parallel connection, I'm going to take this light bulb, and instead of connecting the other one directly to the downstream side of this, I'm going to take this one and connect it over to here. I have my standard circuit again. If I turn the power on, you can see that would work. And so, oh wait, I got to turn this, I got to plug this back in. Thank you. I am a trained professional. Okay, so we're going to try that one more time. And sure enough, we can see that light. So now what I want to do is I want to provide a parallel branch. So off of this, I need another wire coming over. So what I'm going to do is I'm going to take this one and I'm just going to sort of create a daisy chain here. And take this thing over here, connect it to that. Abby, I would like you to help me. I'm going to have this be another branch now. For that, connect that light bulb, that one there, to that one. And then another black wire. And again, we use red and black to maintain polarity, so that we know which side is the positive, which side is the negative. And so we have that one set up. When we connect that one to that one there, you should see that that light bulb turns on because I've just to any part of the metal. And so sure enough, when she connects that there, you can see both light bulbs are on. Okay? This is a parallel arrangement. The current is flowing through this light bulb, returning to the source, and there's another path for the current to flow through that light bulb. What will happen if I pull this one out?
No.
Nothing should happen because the other one has a complete path for it, right? So there's no impact on that. If that light bulb were to burn out, it's faulty, maybe it's got too much voltage across it, whatever, that one will still operate. What would happen if I pull this one out? That's the idea. Okay, so parallel versus series. Now, when you guys go to build your circuits, which I'd like to do on Monday, you're not going to be wiring things from here. You're going to do that on the tables. But you guys can't see it when it's on the table, so I want you guys to see it. Okay? All right, that's the idea. Head in back, please. Everything. All right. How are your homes wired? How are homes wired? Say it again. Are they wired in parallel or are they wired in series? Yeah, they are. You know this, right? And the reason you know that is that if a light bulb burns out in the bedroom, that doesn't cause the light bulb in the kitchen to shut off, right? So these are done in a parallel arrangement. So if you are going to work in an electrical field, and some people do want to work in the electrical field, homes are wired in parallel. So that takes a lot of wiring. So one of the downsides of parallel wiring is that it takes a lot of wire. But the advantage is that you can have things operate independently. As you add more and more devices, there's more current that's moving through the line wires. So as I plug more and more things in, you're going to see that the overall current increases. You notice that I have a lamp, I have a heater, I have a toaster. If I put another device up here, So I can plug in something else. Let's say it's a blow dryer that draws 5 amperes. I can plug in as many things as I want. Usually a circuit will have 12 receptacles, and I can plug in a lot of things. If I do that, what does that do to this current? It was 20. What happens now? I just added 5 more to it, so that turns to 25. And this current, this circuit is only rated for 20 amps. So if I plug in more and more devices in a parallel circuit, what happens is I get more and more current. When the current's excessive, you can get a fire. There are fuses that will melt, but fuses have been replaced. In many cases, they're now replaced with what's called a circuit breaker. If you've ever gone down into the basement where that breaker box is, those breakers, if it trips, you're going to see a red light, that circuit will go down. These are automatic switches that will turn off when the current is excessive. So that's to keep your house from burning down. Okay, and that's because you can plug in a lot of things into those devices. Raise your hand, you're a car person? Like cars? Few people? How is here's a 12-volt battery. Here's a 12-volt battery. In which arrangement would you say you get more light? In the series arrangement, the one on the left, or in a parallel arrangement, the one on the right? In which case would more light be produced? What do you think? By far, it's the parallel. These are going to burn a lot brighter than these. And the reason for that is that these things have to share the voltage. This would be 6 volts, that would be 6 volts, because it's sharing that 12. Whereas the parallel circuit, each of them gets 12 volts because they're connected right to that battery. So if I connect things in parallel, I don't have to share that voltage. Each one gets their 12. And so those things would be a lot brighter. How is your car wired? Your headlights of your car, would you say they're wired in series or in parallel? How do you know? If one headlight goes out, the other one stays on. So that's just an application for wiring for things in series versus parallel. Now, folks, I'd like you guys to be able to build some circuits. I cannot have you build circuits until you know how to connect them up in a virtual environment. So, did anyone get fire produced yesterday when they went to make their circuit using a PET simulator? Anything? You get fire? I don't want to see fire when you guys actually go to build circuits. So I need to know that you can build them correctly. Now, we have series and parallel circuits that I want you to work through to build on a virtual environment. I'm going to stop this video. Those that are watching at home, that's all we did as far as lecture-based stuff.